The next problem. In the circuit shown below, these cells have negligible internal resistance. Determine the current through each resistor. So we have given a circuit diagram, and in which we have to find out the current through each resistors. So look into the figure. We can see the three resistors are connected in the circuit, and it is as in two loops. So in order to find the current through each resistor, we are going to apply Kirchhoff's laws. So for applying the Kirchhoff's laws, we have to apply both laws, and for the second law, we have to specify the direction. So let us have this clockwise direction is taken as the positive direction. So in this loop also we have the clockwise direction is the positive direction. Now first apply the junction rule at the junction B. Okay. So at the junction B, I1 and I2 are the incoming currents, and I3 is going outwards. So when we apply the junction rule at B, we have I3 is equal to I1 plus I2. Now next we are going to apply the Kirchhoff's second law, that is loop rule. First we have to apply the loop rule to the left side loop, that is A, B, E, F, A. A, B, E, F, A. The loop in the left side. That is the sum of the products of the current and the resistance in a loop is equal to the total EMF present in that loop. Okay. And we are taken the clockwise direction is the positive direction. So let us apply the loop rule. So for applying the loop rule on A, B, E, F, A, let us write 4I1 plus 6I3 equals the EMF present in the loop is 12. That is 12. That is equation number 2. Now apply the loop rule in the second loop, that is loop BCDB. BCDEB. Let us apply here I2 in the opposite direction. So negative 3I2. Negative 3 ohm 3I2. And here also I3 is also the opposite direction. So 6 negative 6I3 equals here for the positive direction, that is negative terminal to positive terminal, that is the positive value. But here in the clockwise direction in the loop, the second loop, the direction of the voltage, the EMF, that is the opposite, that is from positive to negative terminal inside the cell. So that 12, that is the negative value. That is, let us write negative 12. So all the terms have the negative value. So let us multiply each term by negative 1. We can write 3I2 plus 6I3 equals 12. That is equation number 3. Now we have to solve these three equations to find the three values of current. So let us see how can we solve it. Let us subtract equation 3. Let us subtract equation 3 from equation 2. 2 minus 3 gives 4i1 minus 3i2. 4i1 minus 3i2. Now the second time we have the 6i3 minus 6i3. So that is cancelled. Then in the right side, 12 minus 12, 12 minus 12, 0. That is 4i1 equals 3i2. That is equation number 4. Now, we have the equation number 2 and 3. Let us substitute the equation number 1 in equation number 2. So let us see how can we write that. 4i1. So I1 from the equation number 1 we have I1 is equal to I3 minus I2. Let us substitute this expression in the equation number 2. Then we can write 4 into I1, that is 4 into I3 minus I2 plus 6 I3 equals 12. Let us expand. 4 I3 minus 4 I2 plus 6 I3 equals 12. So we have negative 4 I2, here 4 I3 and plus 6 I3. So total 10 I3 equals 12. Now this is the, okay, let us see how can we, let us compare this equation with the equation number 3. Compare this equation with let us denote by this equation number 5. So we have the two equations, equation number 3 and equation number 5. Equation number 3, we have 3i2 plus 6i3 equals 12. And equation number 5, negative 4i2 plus 10i3 equals 12. Here we have the two equations with the two variables. So we can solve that equations. Let us, I think we can, equation number 5, we can, again we can reduce, that is negative 2i2, we can divide all the times by 2 plus 5i3 equals 6. Now this is equation number 6. Now here negative 3i2, equation number 3, 3i2 plus 6i3 plus 12, that is equation number 3. So we are going to see, let us multiply equation number 3 into I think it is 2. So what we will get, 6i2 plus 12i3 equals 24, that is equation number 7. Now let us multiply equation 6 into 3. equation 6, that is 2i2. That is another number. Let us multiply with 3. So negative 6i2 plus 15i3 equals 18. That is equation number 8. Now let us add the equation 7 and 8. When we add this 6i2 minus 6i2, that will cancel when we add. So equation number 7 plus 8 gives the first two terms when we add that will cancel out. Then we have 27i3, that is 0 plus 27i3 equals 24 plus 18, that is equal to 42. So from that, i3 is equal to 42 by 27. So let us have a common parameter, that is 3. So here we have 12, here we have 12, here we have the 14 divided by 9. So i3 is equal to 14 by 9 ampere. 14 by 9 ampere. Now how can we find out? Next we have to find out the I2. So for I2, we have the relation connecting I2 and I3. That is, I think, that is equation number 3. So let us substitute in equation number 3 the value of I3. That is I3. Substitute in equation 3. We will get 3i2 plus 6 into I3. That is I3. 14 by 9 equals 12. So that is 3i2, that is here 6. That will cancel out here 3. Here we have 2. So 28 by 9. Uh, 28 by 3. So therefore I2 I can express that is 3i2 equal to 12 minus 28 by 3. So let us therefore I2 is equal to let's divide the right time, all the times in the right side by 3. That is 4 minus 28 by 9. That is equal to 4 minus 28 by 9. That is equal to 8 by 9. That is equal to 8 by 9. That much ampere. That is the I2. Since we have I3 and I1, sorry, I3 and I2, we can find the value of the I1. So I think we can easily calculate it using the equation number 4. Let us move to the, that is 4i1 equals 3i2. 4i1 equal to 3i2. I1 is equal to 3i2 Therefore, I1 is equal to 3 by 4 into I2. So, what is the value of the I2? The value of I2 is equal to 8 by 9. So, 8 by 9. Okay. So, this 4 is cancelled out by 2 times and 3 is cancelled 9 by 3 times. That is equal to 2 by 3 ampere. Okay. So, we have all the 3 values of current. That is I3 is equal to 14 by 9 ampere. I2 is equal to 8 by 9 ampere. And I1 is equal to 2 by 3 ampere. Now have the next problem. Evaluate the current through the resistors in the circuit. Evaluate the current through the resistors in the circuit. That is, we have to find the values of I1, I2 and I3. Okay. Here also, there is a circuit. It consists of the 2 loops. So here also we are going to apply the Kirchhoff's laws. Okay. Look into the figure. Here is a upper loop and a lower loop. And here also we can consider a clockwise direction. Anti-clockwise direction is taken as the the direction for the and this is the positive direction. Okay. Now apply the Kirchhoff's first law, the junction rule at this point. Here the point is not marked here. So at this point we can have I2 equal to I2 is the incoming current, I1 and I3 are outgoing current. So when we apply the first rule, that is the junction rule at this point, we can have I2 is equal to I1 plus I3. Okay, that is equation number 1. Now we apply the loop rule in the upper loop. When we consider upper loop, the product of the current and resistance equal to the total EMF. So anti-clockwise direction is here. It is taken as the positive direction. So that is I can write the 4 I2 plus we have in this the 6 I1. Here that is also positive. The 6 I1 equals, what is here? We have the two sources of EMF, 14 and 10 volt, and both are the positive directions. So 14 plus 10 volt, that is equal to 24. Here that is equation number 2. Now we apply the loop rule in the lower loop. So here I1 is in the opposite directions. So negative 6 I1 and I3 also in the opposite direction. No, I3 in the positive directions. So we are taking the anti-clockwise system. So I here the plus 2 I3 and the EMF is in the opposite direction, so that is negative 10. So let us multiply each term by negative 1. So let us here first term positive 6 I1 negative 2 I3 equals positive 10. That is equation number 3. Now equation I think let us equation 4I2 I1 here I3. Here we have one equation is that let us equation 2 minus equation 3. equation 2 minus equation 3. So that we will get in the left side 6i1 and 6i1, that is cancelled. So we have 4i2 minus 2i3, that is plus 2i3 equals 24 minus 10, that is 14. That is equation number 4. Now let us substitute equation number 1 in equation, I think it is better to equation 2. Equation 1 in equation 2 substitute. So instead of I2 we can substitute I1 plus I3. So 4 into I1 plus I3 plus 6 I1 equals 24. So let us expand. 4i1 plus 4i3 plus 6i1 equals 24. That is 10. Okay. 10i1 plus 4i3 equals 24. That is equation number 5. Now multiply equation 2. I think in auto equation, it is auto equation 3. Equation 3 into 2, and also we can multiply equation 5 into okay, let us see. No need of. First let us multiply equation 3 by 2. So we have 12i1 minus negative 2 into 4i3 equals 20. That is equation number 6. So let us consider the equation 5 and 6. So let us add 5 and 6. That we will get 10i1 plus 12i1. So that is 22i1. Here this 4i3 minus 4i3, when we add, that will cancel out. So 22i1 is equal to 44. From that i1 is equal to 44 divided by 22, that is equal to 2 ampere. So I1 is equal to 2 ampere. Now let us substitute this in equation 5. Okay, substitute the value of I1. The value of I1 in equation 5. Okay, that is I1 in equation 5. Let us write, that is 10 into 10i1 plus 4i3 equal to 24. But 10i1, that is 10 into 2 plus 4i3 equals 24. So that is 20 plus 4i3 equals 24. That is 4i3 is equal to 4, or i3 is equal to 1 ampere. I3 is equal to 1 ampere. Okay. Now we have the two values I1 and I3. Now we can substitute in equation number 1 from equation 1. We have I2 is equal to I1 plus I3, that is equal to 2 plus 1, that is equal to 3 ampere. That is equal to 3 ampere. Now we have the three currents, that is the current through the each resistors. Next, find the currents in the circuit using Kirchhoff's laws. Again we have a circuit. It consists of two loops. So again we are going to apply Kirchhoff's the first law and second law. Okay. So let us apply the Kirchhoff's first law at this point. At this point, we can see that I1 and I2 are going outwards and I3 is the incoming current. So I3 is equal to I1 plus I2. That is equation number 1. Now apply the junction rule, the loop rule in the left loop and right loop. So for that, here also we are going to take the anti-clockwise direction is the positive direction. Okay. Then apply the junction rule at the left loop. We can write I1, 1 into I1, 1 into I1 plus 1 into I3 equals the EMF is 4 volt. That is equation number 2. Now apply the loop rule in the right loop. That is negative here. It is in the current through the here I2 in the opposite direction. So I can write negative 1 into I2, 1 into I2, and also the I3 also in the opposite direction. So 1 into I3 equals here the EMF, the direction of the EMF is also opposite direction, that is equal to negative 2. That is I2 plus I3 equals 2. That is equation number 3. Now, I1 is, let us substitute equation number 1. Let us substitute equation number 1 in equation number 2 in 2. That is the, from equation number 1, we have, from the equation number 1 we have I1 is equal to I3 minus I2. So let us substitute. Let us substitute this in equation number 2. So instead of I1, I can write I3 minus I2 plus I3 equals 4. That is 2I3 plus minus I2 equals 4. Okay. Now let us Now this is denoted by equation number 4. Now let us multiply equation 3 into 2. So that is, we will get I2 plus I3 equal to 2. Let us multiply each term by 2. We have 2I3 plus 2I2 equals, let's say right side we have 2, so 2 into 2, 4. That is equation number 5. Now let us subtract. Now let us subtract equation 5 minus equation 5 minus 4. I think it is better to subtract. I think 2I3 plus when we add this one, 4I3. If we add, we have 2I2. That is not correct. Let us subtract. We have let us 2I3 will cancel out. I have some confusion. Okay. Let us subtract equation 5 minus 4. We have 3I2 equal to 0. That means I2 equal to 0. Okay. Now let us substitute this value of I2 in equation 3. So from equation 3, we have, since I2 equal to 0, I3 equal to 2 ampere. I3 is equal to 2 ampere. And from equation number 1, we have I1 is equal to I3 because I2 equal to 0. Therefore, I1 is equal to 2 ampere. Now we have all the values of current. I1 equal to I3 is equal to 2 ampere and I2 equal to 0.